Hi, Viper chemistry students. Let's take a look at the classification of chemical reactions. And in our slideshow here, we'll just kind of scan down through, and I'll just kind of point out some things as we go. Um, so let's take a look. Okay, so when we look at chemical reactions, we see, or chemists see, about five different types here. Let's just start with the first one here is synthesis. Now, that literally means synthesis. That word means to build up. So, in the case of chemical reactions, you can have two simple element forms, such as the example here, sodium and chlorine. Um, the sodium is representing just an element atom of sodium, and there's two of them, and then chlorine is chlorine gas, and but the two can combine to form salt, sodium chloride, which is a compound. So synthesis means to build up from elements to compound. Okay, let's look at the next one here. Decomposition is when you have a compound and it breaks down to the elements. So in this case, the example is sodium hydroxide. And what literally happens here is that for one reason or another, it's going to break down into two other products, and in this case, it's sodium oxide and water. Now, up at the top, it reads compound down to elements, but in this case, it's decomposing down to other compounds. All right, so let's take a look at the third one here, single replacement, where in this situation, you could start with a single element. And the example here is aluminum. And then it's going to react with a compound. And what ends up happening is the cations replace. So aluminum becomes the cation with chlorine, and then copper then comes out as a single element. So what I want to say here is that the element then becomes the cation of the resulting product compound. So that is a single replacement, which brings us to double replacement. Um, and double replacement is the same kind of idea, except there's just a switching of places here. So, for example, you just have two compounds that are reacting, forming products of two more compounds, but the cations switch places. So, in this case, you have potassium chloride, and the cation there would be potassium. And notice then in the product, the potassium has combined with the nitrate. And so, in the reaction of potassium chloride and lead nitrate, one of the products then becomes potassium nitrate, and the other product is lead iodide, looks like. Okay, so that's double replacement. And finally, the last one here is combustion. Now, this really a lot of times involves covalent compounds rather than binary ionic compounds or polyatomic ionic compounds. This would be more of where you have carbon-based uh, organic molecules that are covalently bonded compounds. And they're really just going through combustion. So, in other words, when they react with oxygen, it's like burning. It's a reaction. It's not always burning like we would associate with a campfire, but similar to that. The products are always carbon dioxide and water, so that's pretty cut and dried and simple to remember. But you'll notice that with combustion reactions, usually we're talking about carbon-based molecules, usually with oxygen, and then almost always we would have carbon dioxide and water as our products. All right, so there are some ways to review here in the slideshow. Your notes cover this very closely. Your notes will uh, follow exactly the way the slideshow presents itself. And then there's some practice problems you can look over, and then this week we'll get some practice with that. Okay, I hope that that makes sense. Keep working hard. I want to say practice makes perfect here. So keep practicing. And as always, let me know if I can answer any of your questions. Thank you for watching.